Assalamualaikum and hi, we are from Group J. We would like to present our assignment titled RC Low Pass Filter. And this is our group members.
Hi, my name is Joanna Netelon, number matrix B0821100062. Today I'm going to talk about passive filter. Our team choose a low passive filter. A low passive filter is a filter that passes signal with a frequency lower than a selected cutoff frequency and attenuated signal with frequency higher than the cutoff frequency. The exact frequency response of the filter depends on the filter design. The filter is sometimes called a high-cut filter or treble cut filter in audio application. A low-pass filter is the complement of a high-pass filter. Low-pass filter exists in many different forms, includes electronic circuit such as filter used in audio, anti-aliasing filter for conditioning signal prior to analog to digital conversion, digital filter for smoothing set of data, acoustic barriers and blurring of image. The moving average operation used in fields such as finance is a particular kind of a low-pass filter and can be analyzed with the same signal processing technique as are used for other low-pass filter. Low-pass filter provide a smoother form of a signal, removing the short-term fluctuation and leaving the long-term trend. So what is transfer function? Transfer function show how the output signal is connected to the input signal at various frequency. It can easily determine the transfer function from a graph of the output signal at various frequency when designing a filter circuit. The transfer function can be calculated using Kirchhoff's law to derive the differential equation that governs the circuit. So, in the type of transfer function, there is voltage gain, current gain, transfer impedance, and transfer admittance. For voltage gain is when voltage output divided by voltage input. This voltage gain is written as below, as above, and current gain is when current output divided by current input. Transfer impedance are the ratio of the output voltage in one mesh of a network to the input current in another mesh. Transfer admittance are the ratio of the output current at one node in the network to the input voltage at another node.
Assalamualaikum. My name is Amarafi Nasrullah Biramli. Today I will present about the simulation of the low-pass filter. As we can see here, I use 1 kilo ohm of resistor and 0.47 microfarad of capacitor. First, I will try 200 Hz. I put in here 200 Hz and the V input is 3 volt and I will run. Here is the waveform and we will get the V max output is 2.57 here. Next, I will try 1 kilo ohm. I will change here to 1 kilo ohm and I will run. Okay, this is the waveform and the output max is 949 millivolt. So here 949 millivolt. And last one I will try 2 kilohertz. Okay, I will change here to 2 kilo and I will run. And we will get 493 millivolt. 493 millivolt here. Okay. So this is the waveform. Yeah, that's all for me. Thank you.
Alright then, thank you Rafiq for that info. Assalamualaikum warahmatullahi wabarakatuh. I bid to Dr. Sharil and the others. So let's continue on our video presentation. is a simple passive RC low pass filter or LPF. It can be easily made by connecting together in series a single 330 ohm resistor with a single 0.47 microfarad capacitor. Now, moving on to the procedures in conducting these experiments. Firstly, we assemble the circuit by connecting the oscilloscopes, channel 1 to the input voltage Vin and adjusting Vin at the frequency equals to 100 Hz on the display of the device with a supply voltage of 3V, which is Vp. Then we connect oscilloscope channel 2 through capacitor C for an output voltage Vout. By doing so, we did get the sinusoidal waves of a 100 Hz frequency, which has been shown by my colleague Rafiq. Furthermore, to obtain more information from the circuit assembled, we increased the frequency of the function generator to the frequencies indicated in table 1 and recorded the value of Vout displayed by the oscilloscope. These are the results obtained by regulating the frequencies, and as we can see that the frequency is inversely proportional to the Vout. Lastly, for further explanation regarding LPF, I will let my respected colleague Ms. Nija to elaborate more on the LPF. Thank you.
My name is Nurul Najib Hamid Rosli, number matric B082110357357. I would like to present the discussion from this assignment. The main things that we have learned from this assignment are about RC low pass filter. A low pass RC filter is a filter circuit composed of a resistor and capacitor which pass through low frequency signal while blocking high frequency signal. To create a low pass RC filter, the resistor is placed in series to the input signal and the capacitor is placed in parallel to the input signal. From the result, as we can see that happened when frequency was increased, the output voltage Vout and phase angle will decrease. From this assignment of RC low pass filter, we conclude that low pass filter pass the signal with high frequency. We can also say that low frequency signal have no difficulty in passing the filter, while it is harder for high frequency signal to pass. Thus, we choose the low pass filter. We can easily build a low pass filter using a resistor with a capacitor. A low pass filter using a resistor and capacitor is called RC low pass filter.